Welcome students. So here we are going to start our topic series RC circuit with DC source. Okay. So this is R and this is C, resistance and capacitance, and this is our DC source. This is the key. So here we are going to find out that what will be the charge on this capacitor at a time t and what will be the current in this circuit. Okay. So let's start now. Let at time t is equal to 0, the key is closed. Okay, t is equal to 0, key is closed. It means now there will be some flow of current. Let at time t the charge on the capacitor is q. Okay, and the current in the circuit is I. Applying KVL in this circuit, KVL means Kirchhoff's voltage law. Okay, so here is EMF of this cell. There will be some potential drop on this resistance, that is I into R, and there will be some voltage of this capacitor also, that is V is equal to Q upon C. So here it is. So here it will be E is equal to IR plus Q upon C. Okay, and we know that I is equal to dq upon dt. Rate of flow of charge is called current. So E, that will be I dq upon dt. R is here plus q upon C. Okay, so it will be E into C is equal to RC into dq upon dt plus q. When we will bring C here and here. Okay, so solving this we will get this. And now we will take this q here, so it will be EC minus q is equal to RC and dq upon dt. Now we will take this dt here and RC here, so dt upon RC and this EC minus q, we will take this EC minus q here, so it will be dq upon EC minus q. Now integrating both sides, here integration with respect to time t and here integration with respect to charge q. Okay, so dt upon RC integration limit from 0 to t, and here dq upon EC minus q limit from 0 to q, because at time 0 charge was 0 on capacitor and at time t charge was small q at capacitor. Okay, so now here when we will solve this, it will be like this, that is 1 upon RC integration of dt, that will be t from 0 to t, is equal to, as we know that integration of 1 upon x is equal to log x, so it will be log of e EC minus q, and differentiation of EC minus q, that will be 0 minus 1, because EC is constant here, so differentiation of EC will be 0 and differentiation of Q will be 1. Limit is from 0 to Q. Okay, so putting upper limit and lower limit, we will get T minus 0 upon RC, and here minus sign will come from here to here, and putting upper limit, that is Q, it will be log base E EC minus Q minus log base E EC minus lower limit, that is 0 here, so EC minus 0. Okay, minus sign will come here, so it will be T upon minus T upon RC is equal to log base E, and as we know that log A minus log B is equal to log A upon B, so this is A and this is B here, so it will be log base E EC minus Q upon EC. Now removing log, we will get e raised to minus t upon RC. This is the property of log, and it will be EC upon EC1 minus Q upon EC. Okay, so now take Q upon EC in this side and e raised to minus t upon RC in this side. Okay, so Q upon EC, it will be 1 minus e raised to minus t upon RC. Solving this, we will get E is equal to EC. This EC is the maximum charge on that capacitor, that is represented by Q naught. So Q naught is equal to EC. So we will put value of EC, that is Q naught. Okay, so Q is equal to Q naught 1 minus e raised to minus t upon RC. This is the equation for charge varying with time t on capacitor. Differentiating this, we will get dq upon dt, because we are differentiating both sides with respect to time. So we will get current I, because dq upon dt is I. So q naught differentiation of 1, that will be 0. Differentiation of this one, it will be minus 1 upon RC e raised to minus t upon RC. Okay, so I is equal to q naught minus minus plus RC will come here, it e raised to minus t upon RC. So now here we can see that at t is equal to 0, it means at starting there was maximum current, that let it is I naught. So when we will put t is equal to 0 and I is equal to I naught here, so I naught is equal to q upon RC, q naught upon RC e raised to 0, and e raised to 0 is equal to 1. So from here we can see that I naught is equal to q naught upon RC. So we can put this as I naught here. Okay, so it will be I is equal to I naught e raised to minus t upon RC. This is the equation for current. Thank you. Thank you very much.